based on our observations, we can graph y versus the number of washers. Okay, well, the number of washers would be 1, 2, 3, 4, 5. So we put those points, and I'm just sketching, but I'm trying to keep those points equally spaced. And we're going to graph the length versus the number of washers. So when there's one washer, the length is 56.5. Now, if this is 25, 50, 75, 100, then 56.5 would be, is 25. 56.5 would be about here, giving us a point on the graph right here. Okay, 61 would be, and if I want to make this pretty accurate, I should probably go ahead and mark this off in 5s. Haven't done a real good job of that, and that really doesn't correspond very well to 56.5. Let's change that a little bit. Okay. Okay, then 61, this would be 55, here's 60, 61 would be here, and that would correspond to 2 washers. So we have a point here. Then 66.5, would be about here. That would correspond to 3 washers. 72.5 would be about here. That would correspond to 4 washers. And 78.5 would be about here, corresponding to 5 washers. Now, do those points lie on a straight line? Well, if I try to make a straight line, say just above those points, we see that there's some curvature to the trend of these lines. And that's consistent with what we found when we calculated these average rates of change, or slopes. They were increasing. The last one stayed about the same, so we probably have a pretty good straight line for these last 3 points, but the trend for the others is to curve upward. The slope increases from 4.5 to 5.5 to 6, and then it stays at 6, as I said. So it appears that the trend here is for some sort of upward curvature, not linear. The graph curves upward. It has increasing slopes. At least the trend is for the slopes to increase. So increasing. Now I'll use ROC for rate of change. And it's not of the form y equals mx plus b.